Hey everyone, great job getting up to this point. So we're going to take a look at page 5 together now that you've finished the previous pages. This page is probably one of the more challenging ones. In this page we're going to look at writing and naming chemical formulas that contain that have compounds that contain polyatomic ions. Now the first thing we've got to do is define that term, polyatomic ion. It's actually a lot simpler than it sounds. A polyatomic ion is just an ion that's made of many atoms. And in fact, that's pretty much literally in the name. If you think about it, poly just means many, right? Like polytheism. Atomic just means atoms, many atoms in an ion. So it's literally an ion, a charged particle, that's made of multiple atoms. So these atoms group together and they bond together and then they travel everywhere together. They're kind of like a gang. They stick together no matter what they do. Okay, so they're usually covalently bonded and they stick together as a group. And so when we write our formulas, we're going to stick them together as a group. You'll see what I mean in just a second here. Some examples of polyatomic ions would be OH, that's hydroxide. And that hydroxide has a negative charge. These superscripts, unlike the subscripts, these superscripts give us the charge of that ion. So here we have CO3, okay? This is carbonate. CO3 has a -2 charge. And many times we'll put the sign of the charge after the number. It's just a wonky thing we do. But it just means that this particular polyatomic atom, or ion, has 4 total atoms and it has a -2 charge. So it's going to react with something that's probably going to want those electrons. Okay, this is permanganate down here. Manganese and 4 oxygens all together giving us 1 charge, or 1 negative charge. Okay, now if you look on the back of your periodic table, you'll see that we've given you a list of very important polyatomic ions. You do not need to memorize these. These will totally be given to you on a periodic, or on an exam for the periodic table. Okay, we'll be giving you something that looks just like this on the test as well. But you can take a look at this, and here we have a list of the different types of polyatomic ions and the type of charge they have. So for example, ammonium has a +1 charge. It's a cation because it's positive. Okay. So it has a positive charge. These negative ions, -1, -2, -3, those guys are more common. Okay, but that contains things like carbonate, CO3, -2, which we saw on the other page, or sulfate, SO4, -2, right? Some of the other really common ones are nitrate, carbide we see every once in a while, hydroxide, and the list goes on and on. One of them that I want to point out to you is this guy, HCO3. This is sometimes called hydrogen carbonate or bicarbonate. It means the same thing. That bi just means there's a hydrogen atom tacked onto it. Okay. So we're going to go ahead and take a look at a problem. So go ahead and turn to page 5, Roman numeral 5, that's a V, of your packet, and let's take a look at this together. We're going to look at example 4 on page 5. So in number 4, we're asked to put together aluminum and nitrate. Now, when you're given these, you're not always going to be told, hey, you have a polyatomic ion here. So you have to kind of think of it. Aluminum we know is an element, right? But you can search all day for nitrate on the periodic table. It's not there. There is no nitrate on the periodic table. There is nitrogen, but this can't be aluminum and nitrogen, right? That would be aluminum nitride ending in IDE. So anytime you see ITE or ATE, something, a different ending, you can almost guarantee, you're almost guaranteed that it's a polyatomic ion. So check the back of your periodic table and see if you can find it on there somewhere. Alright, so let's go ahead and start putting this together. Here we have aluminum, and of course with aluminum we want to look at the periodic table, find it. We know it's a metal, right? So if it's a metal, that means we can use the stock system. Now, it's not a transition metal. It's way over here in group 13, which has a +3 charge, right? If it were one of these transition metals, remember from the last 2 pages, we would need to put Roman numerals in the name, and we would need to figure out the oxidation state first. But we're not quite up to that step yet. So let's just take aluminum, and we're going to bring it back to our table, or to our stock system. But before we go all the way back, I want to take a look for nitrate. Well, nitrate is in this list because it's not on that periodic table. We look at the back of our periodic table onto the list of important polyatomic ions, and sure enough, here it is. NO3 -1, right? This has a -1 charge. It's in the -1 column. So we're going to take this and let's go back to our stock system. Aluminum had a +3 charge. Nitrate had a -1 charge. Okay, I'm going to go ahead and write out the symbols up here for now. We had aluminum Al and NO3. That whole thing is nitrate. That whole grouping of atoms is an ion that has a -1 charge. So now we need to figure out the different number of atoms or ions that we need. We need to figure out what goes on the lines here. And hopefully you see that the only numbers that work other than 0 are 1 and 3. Now you could have 2 and 6, sure, you could have 3 and 9, but remember we want the lowest possible numbers. Okay, and the lowest possible numbers are 1 and 3. This means that I have 1 aluminum atom, so I'm going to go ahead and write that down here in blue. And now I need 3 NO3s. But in order to tell the reader that I need 3 of those groups, I need to package this up really nice and neatly. I need to tie string around that grouping of atoms. I need to put it in parentheses to say everything inside of here is 1 polyatomic ion. And I want 3 of those, right? I want 3 of those polyatomic ions. So this 3 that I've placed on the outside is the 3 from the line. That's applying to everything inside the parentheses, but not the aluminum. Okay, so this is AlNO3 3. Okay, I need both 3s. If I just left it as AlNO3, I would only have 1 polyatomic ion. So it takes 3 of those grouping of atoms to balance this out. Now, that's getting the formula. Now for writing the name. This is the really tricky part. Are you ready? You see this and sign, or and word? And we're done. Aluminum nitrate. We don't need to change the ending at all. We literally just take the words and write them again. Ooh, that turned out weird. Alright, let me try that one more time. There we go. My computer's having trouble keeping up with me. There we go. Okay, aluminum nitrate. So aluminum, the name is just the two words put together, and that's it. So go ahead and try this on your own. Try some of these problems. Read and take notes on page 619 of your textbook. That'll help give you a visual, give you some notes to put down in your notebook, and it'll formalize this. Okay. So make sure you do that, and then try the different problems on page 5, and check your answers in the back of the room. Whenever you're ready, go ahead and watch the next video. See you there.